Welcome to the Swine Health Black Belt Podcast, the latest swine health research digested for you. My name is Dr. Clayton Johnson. I'm the host of the podcast. And joining me on this episode is Nakarin Pamornchainavakul, a PhD candidate from the University of Minnesota. Nakarin, welcome back to the podcast. For anybody who didn't get a chance to listen to that first episode, Nakarin, why don't you introduce yourself and give the audience a little background?
Yeah. Hi, everyone, and hi, Clayton. I'm Nakarin Pamornchainavakul from University of Minnesota. I'm a PhD candidate, and right now I'm working a lot with PRRS and PRRS evolution, and also the dynamics of them. So yeah, I'm interested in that. And my previous podcast is about the recombination of PRRS. For today, I just want to show you the new work that we did with the PRRS prediction.
Let's get right to it, Nakarin. As I understand it, you've looked at genomes, PRRS genomes, historically, and used that to try and build models that would predict the emergence of new PRRS variants. Talk to us a little bit about your work, and most importantly, what are you learning from those model results?
Yeah, sure. So actually, it's not the whole genome of the PRRS, but it is the all 5 gene of PRRS. We have a bunch of that, let's say, 20,000 sequences throughout 10 years, the last 10 years. And we use that data to model the predictive model that can use to predict the next emerging variant of PRRS in, let's say, in the next 12 months or 24 months.
Very good. How many years worth of data have you used, Nakarin, to help develop this model?
It's about 10 years from 2011 to 2020, and we try to simulate like the retrospective data that, let's say, if we have the previous data just only for 12 months, what can we predict for the next 12 or 24 months? And that one would show you like which variant would be the emerging one in the next season. Yeah, for PRRS specifically. Yeah.
Nakarin, do you use the OR5 data because that is the best data to make these predictions? Or do you use the OR5 data because we don't have a lot of whole genome sequencing from that far back?
Actually, that's the answer, the second one. We don't have many whole genome sequences or any other genes of PRRS. So that's why we have to use OR5, which is like the core data we have for PRRS right now in the US. And this is the biggest database we have. And this is the useful one because, you know, in other diseases, for example, flu, they didn't use like the whole genome of flu to predict flu emergence, but they use just HA or NA to predict the emergence of flu as well. So I have to talk a little bit about like the way we predict that. So we just create like the genealogical tree or the tree that's showing the relationship between all the OR5 sequences or the virus we got from the field. And we just use the structure of that tree to predict things. So we find that some of tree features can be used to predict the emergence. For example, the thing called local branching index, or the index that show how rapid each clade branching out from that node. So that will tell you like how fast the virus just like replicates and spread out. And that one, we use that information to predict which one's going to be the next emerging variant. And we found that, for example, if you remember the novel L1C144, the virulent one from the recent year, that one is on the test data set that we didn't use it for the model training. But we found that we can predict that for at least 1 year before the real emergence using this kind of prediction. Yeah.
Do you look at the population type the sample comes from at all? So do you focus, say, on samples from finishing pigs, Nakarin, trying to suggest what may go into the sow herd in future years? Or you take all sequences and utilize them for the model, regardless of the age of pig they came from or the type of production unit that they came out of?
Yeah, for this question, I have to acknowledge the database we use, the Morrison Swine Health Monitoring Project, or MCHIM. We use the data from them to for the prediction, and it is the biggest database for pig, not just within the US, but I believe that within the world. And most of the data not from just finishing pigs. I think less data from finishing pigs, but most of them were from like more than 50% of breeding herds in the US. So I don't think that we use a bunch of finishing herds, but like mostly from breeding herds only. Yeah, that's the problem. But I think at this point of time, we did the best prediction for this kind of data. But in the near future, we can improve this kind of prediction and modeling to not just this kind of data, but also the incoming data in the near future as well.
Yep. Do you think we'll get to a point where we can kind of forecast what the next year's PRRS cycle looks like? Do you think we'll get to a point where we can get to the end of a calendar year and say, okay, we've collected all the sequences that we're going to have through MSHMP or any other programs this year, and then we can, give the industry a heads up or a forecast on what the next year looks like in terms of the likelihood of PRRS viral emergence? Good, bad, or indifferent. Is that possible to get to, or is that more of a pipe dream that no, we'll never probably get that precise with it?
The problem of this predictive modeling is the preciseness as well, because we can just narrow down which one's gonna be the emerging variants, but there are a bunch of false positive at this point of time. We have to train more for this model, but we can narrow them down to just, okay, we should focus on this group. One of them may be the emerging variant. But the problem at this point is not just we spot which one's going to be the emerging variant, but the concern in the field. Because at this point of time, I think most practitioners still use like RFLP typing. Some of them use the similarity between the genetic sequences, but there is no concrete kind of like classification for variant at this point of time. And it's pretty hard to communicate this kind of thing to the field when you have a prediction. So I think we have to improve this point. And also we should have some more knowledge from the immunology side or virology side to get the direct prevention or control that match with this kind of prediction that can be used to integrate with this kind of prediction to help with the control. So I think at this point of time, it's pretty hard to apply this prediction on field, but this is a good start for the future, for sure. Yeah.
As we make progress in applying it to the field, Nakarin, I would assume that this process is independent of geography. And what I mean by that is if there are other countries, other regions with different PRRS strains that might develop a database like MSHMP, where you have a large group of PRRS sequences, that in other countries, the same sort of evaluation could be done. Is that fair to say?
Yeah, it can be done. It's just, we just use the same method. But the problem is the representation of the data, because right at this point for MSHMP data, we're pretty sure that we have like most data that represent the real field. But for other country or region, I'm not sure that how they just get the data from the field, because for MSHMP, it's voluntarily based. When people just notice the outbreak, let's say the practitioner in the field, they just submit the sample or sequence, and like the database just gather them together. But for other country or region, I'm not sure. So that's might be the problem. And the one that we predict might not be the one that would be emerged in the next season.
Yeah. We've got to create the database first. We've got to get all those sequence information. That is the key to unlock predicting the future.
United Animal Health has been innovating nutrition that feeds the animals that feed the world since 1956. Now a multinational ag biosciences company, we help people impact the health of their animals with less labor, less variation, less drag, less challenge, and less natural resources. Learn more at unitedanh.com.
Well, and I asked that knowing that Nakarin, after our first podcast, I got some good feedback from some fellow colleagues that we have in Thailand. And if they're joining in as well for this podcast, hopefully they can help to generate some similar data. And not only in Thailand, but throughout the world, we can apply the work that you're doing going forward. So to our friends in Thailand, Sawadi Krap, did I say that correctly?
Yeah, that's correct.
All right. Well, very good. Thank you very much, Dr. Nakarin, for coming on to the podcast. It's been a pleasure to have you on here again.
Yeah, thank you so much, Clayton.
Well, thanks for being on the show, and to our audience, thanks for listening into the Swine Health Black Belt podcast. Please check out our website at swinehealthblackbelt.com, and don't forget to subscribe to the podcast so that you won't miss out on the next episode. For Nakarin Pamornchainavakul, I am Dr. Clayton Johnson. It's been a pleasure to host you, and please have a great rest of your day.
Hey, everybody. We're always searching for the latest and greatest research to share each week. If you have a swine health-related research trial and would like to come on the show and talk about it, share it with us, please feel free to email the research to hello@wisenetics.com. That's HELLO@WISENETIX.com.
The journey of a hero has challenges, battles, and villains. But after the fight is won, new paths are open, and it's time to catch our breath and move forward. More powerful and super than ever. And you, hero of the swine industry, do you have your cape ready to take new flights? Swine Talks 2023, December 6th and 7th. Together, we're more super than any obstacle.